In this video, we're going to be working on how you find the variance and standard deviation for data, but not just for any data, not raw data, but for group data, or data that's already been arranged in a frequency distribution for us. And so what we're going to do is we're basically going to compare and contrast our method for finding variance and standard deviation using raw data to what we do when we have group data. So what I want to do is consider this thought experiment here. It says, let's consider the following distribution. It represents the scores that 25 randomly selected seniors scored on the ACT. So since these are randomly selected seniors, and it's not every single senior in the United States of America, we're going to consider this as being a sample. So we are going to calculate some sample statistics here, starting with the mean. If I wanted to find the mean for this grouped frequency distribution, what we would have to do is start by finding, well, what does all the data add up to and how many data were there in the first place, okay? So in terms of finding the mean, the thing with finding out how many data there were in the first place, we could just add up all the frequencies. We could say, well, how many total data there were? If I wasn't told that there were 25, we could say, well, 3 plus 8 is 11, plus 10 is 21, plus 3 is 24, plus 1 is 25. So the very first thing I want to find out is lowercase n, since it's a sample here, how many data there are, and of course there are 25 total data, and I'm going to list that here. Now, what I would like to do is find the sum of all of our data. The thing here is we do not have the raw data. I can't just say it's the sum of all the x values because I don't know the x values. All I can tell you is that I know that 3 people got somewhere between a 12 and a 16, 8 people got somewhere between a 17 and 21, and so on and so forth with these remaining classes here. So what we're going to do is this. We're going to build onto our table, okay? And we're going to have to build on actually quite a few columns in this video, but the first thing we're going to do is we're going to assume that since I don't know what everybody got in each of these classes, we're going to say that everybody got the class midpoint, okay? We're going to assume that everybody scored right in the middle of each of these classes. So for instance, if we wanted to calculate the class midpoint, recall that the class midpoint is the average of the lower class limit and the upper class limit. So for instance, if I found the average of 2 and 6, we say 2 plus 6 is 8. 8 divided by 2 is 4. Okay, we're going to populate this with the 4. And we say, all right, what's the average of 7 and 11? Well, 7 plus 11 is 18. 18 divided by 2 is 9. And as a matter of fact, I could do this with the remaining classes, but I want everybody to notice here, the class width for each of these classes here, from 2 to 7, it went up 5. From 7 to 12, it went up another 5. And goes up another 5 from 12 to 17. So all of our class midpoints to get to the next class midpoint are also going to go up 5. So this next midpoint should be 14. You can see that that's reasonable here. Add another 5 onto this, you get 19. 19, of course, is between 17 and 21. So I'm going to keep adding 5s on. I say 24 is this class midpoint. 29 is this class midpoint. The last class midpoint would be 5 plus 29, which is 34. Okay, all the way up to, oh, whoa. Let us zoom back out here. Sorry about that. All right, that's better. That's a little too far. Let's see if I can get it about right there. Okay, so I apologize for that. But essentially, we got the class midpoint for each of these. Since we're assuming that everybody scored at the class midpoint, then what I can tell you is we kind of have the raw data now. I know that 3 people we're going to assume got a 14, and 8 people got a 19, and 10 people got a 24. I want to add all these numbers up. So the nifty way of doing this, and the way that we tend to employ is this. We're going to take the frequency for each class times the midpoint of each class. So we'll take the frequency in the first class, 0, times the midpoint of the first class. In other words, we got 0 4s. What would that add up to? Well, 0 times 4 is 0. And again, here we have 0 9, so that would add up to 0. If we had 3 14s, now this is where we need to get out our calculator maybe here. We say 3 times 14, what would those add up to? We get 42. Okay, 42. We say 8 19s. If we had 8 19s here, we say 8 times 19 is going to be 152 in this class. 152. 10 times 24, of course, is 240. We say 3 times 29, that would be 81. Sorry, I just kind of did that mentally there. 1 times 34, of course, is 34. What we wanted to do is find the sum of all the data. So what you're looking at here is all the sums of each individual class's data. What we're going to do is we're going to add up this entire column. And I'm actually going to write this at the bottom. And what we do is we call this the sum of all of our data, or the sum of f times xm, or the sum of our frequency times class midpoint. And what we get in this particular instance, and I'm going to write that down here as well, we say the frequency times class midpoint. We want the sum of all of that. Let me clean this up here. We have the sum of our frequency times class midpoint. And what these all add up to, and we just need a calculator to do this, is going to be this. We have 42 plus 152 plus 240 plus 81 plus 34. So we get 549. And I like to write sums at the base of our columns here. So 549, we say 549. So the first thing we want to do is calculate the average here. And we said that the average would be the sum of our data all over what, how many data there were, our n value. And so in this particular instance, our 549 divided by 25, we would say that the average score was about a 21.96. And we're going to call this a 21.96 score approximately, but we're going to round off to the nearest tenth. You notice that we would round that up to a 10 there. So we get approximately, and we're going to write 22.0. You actually want to include the 0. We're going to go one extra place value than the original data. So now we've found the mean. What we want to do is calculate the variance and standard deviation. The thing here is this. I say what information is needed to use the shortcut for the variance and standard deviation. Now in the previous video we said for variance for a sample there are 3 things we need to know. We need to know how many data there are. Now keep in mind we already found this when we found the mean. We say we also need to know what all of the data adds up to, and we already found this when we found the mean. The only thing we haven't found is the sum of the data that we get when we square the original data, and that's this sigma x squared. So you're going to notice that the formula for finding sample variance and standard deviation for grouped data, that is data in a table, says that we're going to do all of this right here. And I just want to do a little compare and contrast here. They both have an n. They both have the sum of the squared data right here, except for we're going to write it slightly differently. We're going to write it as the sum of the frequency times our class midpoint squared. So our class midpoint, if this represents the original data values, what we're going to need to do is we're going to need to build in another column where we square all of those original midpoint values. And we're going to have to take those squared values times the class midpoints, okay? So we have to build in 2 more columns here. And then we also need now the sum of our data, which is this thing right here, which we already have squared, and this is all over n times n minus 1. So it's really the same process, we just need to build on some extra columns. So in terms of what are our class midpoints squared, well, 4 squared is going to be 16, and 9 squared is going to be 81. We get 14 squared is 196. 19 squared, I have to think about this one. I think it's 361, but we get 19 squared is 361. We need 24 squared. 24 squared is 576. So 576, this is 361. We need 29 squared and 34 squared. So 29 squared is 841, so we get 841, and then 34 squared is 1156. So what we are going to do in this particular instance is this. We're going to go back and take all of our frequencies, these original frequencies, except for instead of taking them times the class midpoint, we're going to take them times the squared class midpoint. So we get 0, which was our first frequency. This time times 16 is still 0. We get 0 times this 81 is 0. So here's where we need the calculator. We say 3 times 196. So we get 3 times 196. We get 588, so 588. We get 8. Now 8 times our squared class midpoint, so 8 times 361. So 361, we have 8 of those squared data values. So we get 2888. Now we're going to say 10 times 576, which we can just add a 0 onto that. We say 3 times 841. So 841 times 3 is 25, 23, 25, 23. And then last but not least, 1 times anything is itself. So 1 times the squared class midpoint is just itself of 1156. And what we're going to do down here is we're going to find the sum of all of these values. So just like we did with our frequency times class midpoint, the only difference when you do standard deviation with grouped information is you need to take also the frequency times the squared class midpoint. And that's going to represent, the sum right here is going to represent the sum of our squared data. So plus 2888 plus 5760 plus 2523 plus 1156. So this adds up to 12915. So we say 12915. And I'm actually going to write that down. So we say N25. The sum of our data, that is frequency times class midpoint, was 549. And then the sum of our, not data times the frequency, but squared data times the frequency was this 12915. So when we use this formula now for variance of a sample, we'd say that it's S squared, and we get the same calculations we were carrying out before. So we'll start with this. We have n, and then n times n minus 1 in the basement. So our n, in this case, we have 25 students that did this. And in the basement, we'd have 25 times 25 minus 1, which is 24. And then as far as these other two numbers that we have on the top go, we say this minus this number squared. We're going to put in the bigger of the two numbers first, the sum of our squared data, which was this 12915. And then we are going to subtract the sum of our data squared. And so this right now, this is the variance. As a matter of fact, dudes, you could just say I'm done. We do want a decimal though, so we're going to carry this out. So in the basement, 25 times 24. I do like to do that one first. We get 600, and even 600. So we say over 600, and then on the top here, let's get our calculator back out. We say on the top, let's clear this out, 24 times 12915 equals, and we're going to subtract off 549 squared, and what we get is this difference of 8559. So we have 8559. So now we will carry out this calculation. We say that divided by that 600 that we had in the basement, our sample variance is 14.265. And I don't want to round this yet. I don't want to round until the last step when we get to standard deviation. But here's my favorite part about this. If this is our variance, then to get the spread of our data, just S, we say S is the square root of our S squared, which means really it's the square root of this number we just found, this 14.265. And so leaving this up on my calculator, I could just say, well, hit the square root button, check this out, and we're going to go out to one extra place value that our original data did, and this went out to the nearest whole. So we say going out to the nearest tenth here, 3.77, we're going to call this 3.8. So basically, what we have just discovered is this. I want to say points. Okay, we should be labeling these things here. Basically, we found out that the average score is about a 22-point score on this ACT, give or take about 3.8 points on average. And that is how you would calculate the standard deviation, the variance for grouped data. Cheers.